Hi, this is the Tech Digested by Delta. In today's episode, we will do a quick dive into the state of 6G as of 2026. To understand current developments better, let's briefly go over history of mobile networks. The first analog cellular network was deployed back in the late 70s. First generation of mobile networks was an analog system deployed across several regions and countries worldwide. The first commercial deployment of the mobile cellular networks was in Japan in 1979, followed by other countries worldwide. 1G was an analog voice service which was using analog radio signal modulation and was not encrypted or secure. However, it was revolutionary because first time ever the service areas were divided into small chunks, cells, that led service providers to use lower power base stations and enabled frequency reuse. To overcome analog system limitations, such as low voice quality, susceptibility to radio interference noise, and lack of security, in the start of 80s, a new second generation GSM standard was developed, which saw its first deployment in 1991 in Finland. This GSM standard was again revolutionary, because it has introduced several new concepts. Over GSM networks, people could use short messaging service to send short text messages. MMS gave capability to send a multimedia message. Later specifications such as GPRS and Edge introduced data transfer, essentially enabling mobile device internet access. Also, GSM introduced Subscriber Identity Module, SIM, which let subscribers to change their numbers or carriers quickly by simply changing the SIM card. In early 2000, 3G was introduced, which enabled more broadband-like internet access for users. 3G significantly increased network speed, enabling general internet browsing, video calls, online gaming. Later specifications of 3G enabled internet speeds up to 42 megabits per second. In the start of 2010s, 4G network rollout started across the globe. The 4G network introduced broadband internet access speeds up to 1 gigabits per second, capability to stream HD videos, and was first network generation that was geared up not only for human users, but also for Internet of Things, IoT, distributed edge computing devices, thus starting major transition that continued later on. In 2019, the first commercial 5G networks was launched in South Korea, and other countries quickly deployed 5G networks through early 2020s. The main advantage of 5G network is low latency, which enabled even faster real-time communication for connected devices. 5G networks are even more geared up towards IoT and machine-to-machine communication than 4G networks. Also, for the first time, 5G has seen rapid private deployments for enterprise users, as it can accommodate a lot of connected devices at the same time. As of 2026, 6G standard is in active development by several organizations and companies under 3GPP. 6G will be geared up to non-human users to a greater extent than its previous generations, accommodating seamless communication between AI agents, autonomous cars, drones, IoT nodes, and sensors. Also, the standard development is more focused on data uplink rather than downlink, as it should enable connected devices to send data quickly with minimal downtime and latency. As such, connection speed also should increase between cell towers, base stations, to internet backbone, main network. It also might utilize sub-terahertz or terahertz frequency bands to enable faster speeds and lower latency than its previous generations. Utilizing these frequency bands also will enable location services with centimeter precision without GPS need. Additionally, this might enable creation of cities' digital twins, as the cell towers essentially can use AI to create cities' 3D radar maps with live tracking of car and human movement. This can have huge benefits for modern cities. However, This also raises a lot of privacy concerns with respect to unwanted tracking of people on cars that are not even using 6G. Another integral part of 6G will be non-terrestrial networks integration, for example, usage of satellite networks. As of now, we can see that modern iPhones and Samsung phones already have satellite connectivity integrated in their smartphones in a form of SMS, that users can send in emergencies using satellites if ground-based networks are unavailable. In 6G, satellite networks will be accessible for data and voice communication practically covering entire globe. Of course, terrestrial networks will have advantage with respect to latency and speed. However, non-terrestrial networks integration will enable seamless access for devices everywhere. A lot of companies and customers alike are looking forward to this new generation of mobile networks. There they can achieve more productivity and profit by utilizing this cutting-edge technology. However, some skeptics say that 5.5G networks are enough for decades to come and development of 6G is just waste of time and resources. Plus, it has significant privacy drawbacks that will be hard to address. What do you think?